Finding unknown inputs. In this video, you'll learn how to explain the meaning of a solution to an equation in terms of a situation. You'll also learn how to write a quadratic equation that represents a situation. A quadratic equation represents a situation where the relationship between two variables forms a parabola. The solutions, or roots of a quadratic, indicate where a function reaches a particular value. To model a quadratic equation, we'll identify the given and unknown values, write an equation to model the problem, and then solve for unknown values using algebra or graphing methods. Here's a diagram that shows the picture with a frame that is the same thickness all the way around. The picture is 7 inches by 4 inches, and the frame is created from 10 square inches of framing material. So we're going to analyze the situation and try to pick out the pieces that can help us write an equation. We know that the picture is 7 inches by 4 inches. So we'll put this on our picture so we know how much the length and width is. And since we know the length and width, we can say that the area is 28 inches squared, since 7 times 4 will give us 28. And we also know that the frame is created from 10 square inches of framing material. So that means that the area of the frame must be 10 inches squared. So now we're going to write an equation that represents the total area of the framed picture. We know that the area is the length times width. And we know from what we were given that the area of the picture is 28 and the area of the frame is 10. So if we add those together, then we'll get an area of 38 inches squared. To find the length, we'll take the 7 inches in our picture, and then we'll add the value of x on each side to represent the width of the frame. We don't know the frame's width, but we do know that it's the same all the way around, so we'll just call it x for now. So our length will be 7 plus 2 x's. And then we can find our width by taking the 4 inches that are in the picture and adding an x on both sides to represent those frames. So our width is 4 plus 2x. And now we have all our variables filled out for area, length, and width, so our equation is complete. In this example, a girl throws a paper airplane from her treehouse. The height of the plane is a function of time and can be modeled by the equation h of t equals 25 plus 2.5t minus 1/2 t squared. Height is measured in feet and time is measured in seconds after the airplane is thrown. We're going to evaluate h of 0 and then explain what this value means. So let's take the equation they gave us, and we'll replace h with 0. We'll put this in a new frame so we can see all of the steps. Let's start by squaring the 0 that we have. Squaring 0 just gives us 0, and then if we multiply that by the 1/2 that we have, we'll get 0 again. Now we'll multiply the 2.50, which also gives us 0. So now we'll just add 25 plus 0 minus 0, which gives us a value of 25. So h of 0 equals 25 tells us the initial height of the paper airplane. So the girl's treehouse is 25 feet tall. Now we're going to decide what would a solution to h of t equals 0 mean in this situation. H of t equals 0 tells us the time when the airplane hits the ground. This is because 0 represents 0 feet. Now what does the equation h of 9 equals 7 mean? We can see in our equation that h of t represents the function. And in our example we have h of 9. So this tells us that t is 9 seconds. The 7 will tell us that it's 7 feet above the ground. In this example, a square picture has a frame that is 3 inches thick all the way around. The total side length of the picture and frame is x inches. We'll write an expression that represents the area of the square picture without the frame. So we'll draw a shape that represents a square picture that has a frame of 3 inches. We know that the frame is 3 inches thick all the way around. So we'll put 3 inches in to represent this in our frame. We also know that the total side length of the picture in the frame is x inches. So this tells us that the entire width of the frame and the picture is x units. If we want to find the length of just the inside of the square, then we'll take the width of x and subtract 3 twice, since we have 2 frames on each side of 3 inches, which simplifies to x minus 6. So now we can find the area of the picture by taking x minus 6 and squaring it, since the length and width are the same in this square. In our final example, we have that the revenue of a youth league baseball game depends on the price per ticket, x. And this graph represents this, where the x-axis represents the ticket price and the y-axis represents the revenue. So I'm going to put up a few statements and we're going to decide if they're true or false. The first one says that R of 5 is a little more than 600. If we go to where x is 5 and we go up until we hit the line, we can see that it does hit at 600, so this one is true. The next one says that R of 600 is a little less than 5. But if we look at our x-axis, we actually don't have an input that is up to 600, so this one is false. The next one says that the maximum possible price is $15. So if we look at our x-axis again, we can see that the largest x value that our function hits is 30 and not 15. So this one is false as well. This one says that the maximum possible revenue is about $1,125. If we go to the vertex that represents our maximum point, we can see that the y value is around 1,125. So this one is correct. And our last one says that if tickets are $10, then revenue is $1,000. So let's go to our input of $10 and see where it hits our function. We can see that it hits at 1,000, so this one is true. Now let's recap what we've learned. Functions represent the relationship between two variables, the input like time and the output like distance or cost. And graphs help visualize the relationship between inputs and outputs, making it easier to identify trends, patterns, and the type of slope.